Hi, good morning. We're going to start Unit 9's review right now. This is from page 822, number 1. I'm only going to do number 1 because number 1 through 3 has to do with this figure, this parallelogram, and it's very important for you to do the unit review, the majority of it on your own, so you can build the skills that you'll need to pass the test. So we're trying to find the measurement of WZY. WZY is right here. Essentially, since we know angle ZWX right here, these two angles together, I'm just going to say angle W plus angle Z, they add up to 180 degrees. So the measurement of angle WZY is equal to 180 degrees minus 105 degrees, and that's going to give us 75 degrees. So this unknown angle right here is 75 degrees. Okay, so the next problem we want to do is number 5. Number 5, I believe, is looking at, it says, find the value of each variable in each parallelogram. So again, it's just like the problems that you're going to do, number 1, 2, and 3. So we have this parallelogram that looks like this. It's W, X, Y, and Z. And there are two diagonals that go across and connect the opposite sides. And we have right here 8, 6, S minus 7, and 2t minus 6. And it says find the value of each variable in each parallelogram. All right, so a property that we've looked at in previous sections tells us that these diagonals, so WZ is equal to diagonal YX. And what we could do is we can also look at the length of the diagonals. So wherever they intersect, it basically creates two equal segments. So what I'm going to do for YX, that's going to equal S minus 7 plus 6. All right? And so what we could do is to find half of it right here, this section, and this section to solve for the variable s. We could just take s minus 7 and equal it to 6, because these two lengths, even though I drew a parallelogram that doesn't show it, these two lengths right here for y and x are equal to each other. So I'm going to just add 7 to both sides, and s is going to equal 13. All right, we're going to do the same thing for t. So for w, z, we know it's equal to these two components added together, which is 2t minus 6 plus 8. And in order to solve for the variable, we know that 2t minus 6 equals 8. So we're going to set 2t minus 6 equal to 8. We're going to add 6, 2t equals 14. Lastly, we're going to divide both sides by 2, and t equals 7. So again, in order to find the variables, we looked at the diagonals, and since these two parts right here of the diagonal are congruent to each other, and these two parts are congruent, we're able to set them equal to each other and solve. All right, so now we're going to look at another problem. Problem 6 has to do with a parallelogram, and problem 7 the same thing. What I'm going to do is let you work on those on your own, because they are the same type of problem. basically as number 5. They're just a little different. Since 8 and 9 are the same type of problem, I'm going to actually do one of those for you, and then we will continue on. So I think I'm going to do number 9. All right, so for number 9, it says, find x and y so that each quadrilateral is a parallelogram. So we have a quadrilateral that kind of looks like this. And it says, oh, I was drawing number 8. So we have a quadrilateral right here. It has a side of 3x minus 2, an opposite side that's 2x plus 6, 4y plus 6, and 6y minus 8. So in order to solve for the variable, since these are opposite sides in a parallelogram, essentially they're congruent. So that means we could set 3x minus 2 equal to 2x plus 6 and solve, and also 6y minus 8 to equal 4y plus 6 and solve for y. So I'm going to add 2 to both sides, and I get 3x equals 2x plus 8, and I'm going to subtract 2x, and I'm going to get x equals 8. All right, and then I'm going to subtract 4y to both sides, and I get 2y minus 8 equals 6. I'm going to add 8, 2y equals 7, or 14. And I was already doing it in my head because that's why I said 7, because I divided by 2 on both sides, and I get y equals 7. Okay, so that is problem 9. So problem 11 is a multiple choice problem. It wants you to determine which of the following quadrilaterals is not a parallelogram. This has you look at the theorems that we've discussed, and essentially the answer would be D. Even though it looks like a parallelogram, all we know is that these two opposite sides are parallel. We do not know their lengths though. So in order for it to be a parallelogram, it would have to have a congruency statement like number A. And since it does not have the congruency statements, we don't know if these two parallel sides are the same length. And a parallelogram is going to have two opposite sides that are not only parallel, but have the same length. And since it's not classified as having the same lengths, we know that D would be our solution. All right, so let's move on to the next problem. So we're going to be doing number 12. Number 12 says determine whether the figure is a parallelogram. Justify your answer with the method indicated. So it wants you to use the distance formula and we have vertex A at -6, -5, vertex B at -1, -4, vertex C at 0, -1, and D is at -5, -2. So I am going to graph these vertices. So we have -6 and -5. So right here is A. We have B is at -1, -4, right here. C is at 0, -1, and that is right here. And D is at -5 and -2. And that is pretty much the shape or the points. And we got to look to see if this is a parallelogram. So even though this, based on my drawing, looks a little off, it could be because my separation between the axis hash marks could not be drawn to scale. So essentially, what we're going to do is use the distance formula, because we know that the opposite sides should be congruent if it is a parallelogram. So that means that CD has to be congruent to AB, and AD has to be congruent to BC in order for this quadrilateral to be classified as a parallelogram. So we're going to use the distance formula. And that is the square root of x2 minus x1 squared plus y2 minus y1 squared. And for CD, we know that we have a point at 0, -1, and D is at -5, -2. So we're going to just plug that into the formula, and we're going to go -5 minus 0 squared plus -2 minus -1 squared. That's going to give us -5 squared plus -2 plus 1 is -1 squared. So that's going to give us the square root of 25 plus 1, so that's the square root of 26. So let's look to see if that is equal to AB. A's coordinate is at -6, -5, and B's coordinate is at -1, -4. Doing the math, we're going to have -6 minus a -1 squared plus, or the square root of -6 minus -1 squared plus -5 minus -4 squared. So that's going to give us the square root of a -6 plus 1, that's going to be -5 squared plus -5 plus 4 is -1 squared. So that's going to give us the square root of 26. So we know that CD is congruent to AB. Since they were equal to each other, we have to actually continue on. If they weren't equal to each other, meaning one opposite side lengths of the quadrilateral weren't congruent, then it wouldn't be classified as a parallelogram. So now we're going to have to look at AD, and A's coordinate is at -6, -5, and D is at -5, -2. Doing the math, we're going to have -6 minus the square root of -6 minus negative 5. Sorry, my Bluetooth just went off. And we're going to have negative 5 minus a negative 2, and then square that. So we're going to have negative 6 minus a negative 5 plus negative 5 minus 2. So that's going to be the square root of negative 6 plus 5. That's going to be negative 1 squared plus negative 5 plus 2. That's negative 3 squared. And that's going to give us the square root of 10. So if BC's length is equal to the square root of negative 10, then we know that this quadrilateral is classified as a parallelogram. So B's coordinate is at negative 1, negative 4, and C is at 0, negative 1. We're going to plug it into that formula for the distance formula. We're going to have negative 1 minus 0 squared inside the radical. And we are going to have plus negative 4 minus a minus 1 squared. So the square root of negative 1 minus 0, that's going to be negative 1 squared plus negative 4 plus 1 is negative 3 squared. So that's going to also give us the square root of 10. So since AD, CD is congruent to AB and side AD is congruent to BC, we know that this is in fact a parallelogram. Yes, ABCD is a parallelogram. All right, so that concludes problem 12. So we are going to keep going on to the next problem. So problem 17 is another problem that has you do the theorems. And problem 18 is the same thing. So basically what you're going to do is go to the section on parallelograms and study the 4 theorems that we've looked at to determine if a quadrilateral is a parallelogram. And your response is going to say, yes, according to theorem so-and-so, this quadrilateral is a parallelogram because yada, yada, yada. So I'm going to skip over 17 and 18 because I want you to go back and look at the parallelogram theorems and go from there. So then the next problem I'm going to do is number 25 and 23. 25 through 27 looks at a rectangle in the properties. Since they're all based on the same diagram, I'm only going to do 2 of the 5 problems, and you are going to be responsible at doing the other 3 for practice. This is going to be in the section about rectangles, so if you are a little bit confused, definitely check out lesson 3 and all of the pages, because that's the section that we did for going over rectangles. So problem 25, this was kind of out of order because it had 25 and then 23. I am going to draw the rectangle that we're looking at, and it is EFGH, and then it has diagonals, and then the intersection point of the diagonals is K, and then it has a 90-degree angle right there. So essentially for 25 it says if FK is equal to 32, find EG. So it says FK is equal to 32. So right here, and then it wants to find EG, that entire length. According to the properties of rectangles, this is from lesson 3. We know that in a rectangle, these little segments are congruent. So it means that HK is equal to FK. So that means that this other portion is 32 units in length. And so we know that since FH is congruent to EG, we just need to look at basically FH's total length, and we determine that the length of diagonal FH is FK plus HK, and that's going to be 32 plus 32, which is 64 units. So that means that diagonal EG is equal to 64 units. And I just want to tell you where lesson 3 begins in the textbook. I think my textbook is a little bit bigger, but it is in 13:3, and there is, let's see, basically there is a theorem on page 823. It's 13.11, diagonals of a rectangle. As I stated, the diagonals are congruent. So that means that they're equal to each other, and when you split them into two segments, they're going to be also congruent as well. All right, so let's go on to the next problem. I'm going to do number 23 and have you do the rest, 26, 24, and 27. They all have to do with this diagram. So I'm going to erase what I drew up here. And it says that the measurement of FEG is equal to 57 degrees. Find the measurement of GEH. So it says FEG. FEG. So it's this little portion right here is equal to 57 degrees. And it says that find GEH. So GEH. So it wants this little section. Well, we know that those two angles form a 90-degree angle. So in order to solve for GEH, we're going to take 90 degrees, because the whole angle, and subtract FEG, which is 57 degrees. And that is going to give us 33 degrees. All right, so let's move on to the next type of problems, and that is going to be looking at rhombuses on the next page. I am going to make another video, but I need to do something real quick. I think a student was contacting me, so I will definitely get back to you with the remaining unit review and post that by today. All right, take care.